Hello, everybody, and welcome to another episode of What's Up with the Universe. I'm your host, Eli Hugh, and I want to welcome everybody here who's joining me live or who's doing a rewatch. And I will try to talk slowly because I hopefully have enacted the closed caption live button feature. So anybody who has difficult hearing or hard of hearing or is deaf can actually hopefully follow along. Hopefully I have this correct. If not, it should be in the replay closed caption. And I apologize for who's watching this live if you have a hard time hearing. I apologize also about last week because, well, I was a little busy last week doing other stuff. So today we are going to be talking about the universe. Yes, but before we do that, I want to say hi to, I want to say kapla to the first person who was in here, Bird of Prey 5, kapla bird. And of course, my little favorite quantum physicist, Yvette. Hey, Yvette. Okay, today we are actually talking about the universe. So, what is the universe? I mean, well, the universe is everything. Yeah. It actually includes all of space and all of the matter and energy that space contains. It even includes time itself. And of course, it includes you. The Earth, the Moon, they're all part of the universe, as well as the other planets and many of the dozen moons out there, along with asteroids, comets, the planets orbiting the sun, the planets orbiting other suns. I mean, well, the sun, for instance, it's one among hundreds of billions of stars in the Milky Way galaxy. And most of these stars have planets of their own called exoplanets. I mean, the Milky Way is but one of billions of galaxies in the observable universe. All of them, including our own, are thought to have a supermassive black hole at their centers. Yes, all of the stars and all the galaxies and all other stuff that astronomers can't see or observe are all also part of the universe. It's simply everything. This image you see right here, this is the star-forming nebula W51. It's one of the largest, quote-unquote, star factories that astronomers call in the Milky Way galaxy. Star factories like this one, they can operate for millions of years. As you can see in the image here, the red region on the right is older, which shows that evidence in the way it has already been carried out by winds from generations of massive stars. Those are at least 10 times the mass of our own sun. The dust and gas in the region, they're swept around even more when those stars die and explode as supernovas. I mean, on the nebula's younger left side, many stars are just beginning to clear away gas and dust. I mean, wherever you are right now, outer space is only 62 miles away. Yes, no matter where you are on the planet, look up, outer space is 62 miles up. Or for non-Americans, it's about 100 kilometers. You know, space is also below you, about 8,000 miles or 800 kilometers below your feet. On the outside of the Earth looks the unforgiving vacuum and radiation of outer space. So yes, in fact, technically you are in outer space right now. But Earth is a planet and it's in space and part of the universe, just like every other planet. I mean, it just so happens that things live here on the environment near the surface of this particular planet is only hospitable to life as we know it. So far, we know that Earth is just a tiny, fragile example of life and possibilities in the cosmos. I mean, okay, Earth itself. How old is Earth? Well, for nearly 2/3 of the time since the universe started, Earth didn't even exist. Of course, it's not going to last forever. I mean, several billion years from now, approximately 5, the sun is going to basically supposed to expand and swallow Mercury and Venus, and it'll basically be in Earth's night sky. It might even expand enough to swallow Earth itself, like Doctor Who. Of course, it's very difficult to be certain. We do not know the exact outcome of our own star and how much it will expand. It might even blow Venus toward Earth and crash into Earth. We don't know yet. I mean, what the distant future is very difficultly accurately to predict. The distant past is slightly less so. See, by studying the radioactive decay of the isotopes on Earth and in asteroids, scientists have learned that our planet and the solar system formed about 4.6 billion years ago. And we were only on this planet for just a small fraction of that. I mean, hey, how old is the universe? Well, on the other hand, the universe appears to be about 13.5 billion years old. Scientists arrived by that number by measuring the ages of the oldest stars and the rate at which the universe expands. They also measured the expansion by observing the Doppler shift in light from galaxies, almost all of which are traveling away from us and from each other. The farthest galaxies are faster. I'm sorry. I need a drink. That's butter. Well, Bird of Prey, whoever you heard that from is incorrect. I was talking about the Doppler effect. See, the farther galaxies are, the faster they're traveling away from us. One might expect gravity to show the galaxy's motion from another, but instead they're speeding up, and scientists don't know exactly why. Sometime in the future, galaxies are going to be so far away from us that light will not even be visible from Earth. Basically, the matter and energy and everything in the universe, including space itself, was more compact last week than it was today. Yet, the same can be said at any time in the past. Last year, a million years ago, a billion years ago. But the past doesn't go on forever. By measuring the speed of galaxies and the distances from us, scientists actually found that if we can go back far enough before galaxies formed or stars began flushing hydrogen into helium, things were basically so close together and hot and dense that atoms couldn't even form and protons had nowhere to go. You go a little bit back further in time, everything goes in the same spot. Or really the entire universe, not just matter in itself, was in one spot. Sounds like sorcery to me. Yeah, to quote Spider-Man, witches. I mean, don't try to spend too much time actually considering if you can actually go visit where the universe was actually born. Nobody can actually visit where the Big Bang happened because it's not that the universe is dark. Empty space and expansion happened from which all matter sprang forth, which basically means the Big Bang happened there. It happened there. It happened way over there. It happened here. It happened over there. It happened behind you. The Big Bang happened everywhere at the same time. I mean, the universe didn't exist. Space didn't exist. Time is part of the universe, and so it did not exist before that. Time too began with the Big Bang. Space itself expanded from a single point to the enormous cosmos and everything else you see around us right now. I mean, people want to know, what exactly is the universe made of? Well, the universe contains all the energy and matter there is. Much to the observable matter in the universe takes from the form of individual atoms of hydrogen, which is the simplest of atomic elements. It's made up of only a proton and one electron. If the atom also contains a neutron, it is instead called a deuterium. Two or more of these atoms sharing electrons is a molecule. Yes, I'm giving you a little subject here. Just a little small bit. I mean, many trillions of atoms together is just a dust particle. Smush a few tons of carbon, silica, oxygen, ice, some odd metal, tin, I was gonna say tin, metal, tin, that sort of stuff together, and you got yourself an asteroid. Or collect about 333,000 Earth masses of hydrogen and helium together, and you have a sun-like star. And we are graced by LDG, Nerd Geeks Enjoy Erotica. You thought deuterium was heavy. Well, it could be, liquid. This spectacular image right here, this is from the Sphere instrument on the ESO, VLT. Sorry, Very Large Telescope. This is the very first clear image of a planet caught in the very act of formation, accretion. Yes, this was found around the dwarf star PDS 70. The planet stands clearly out, as you can see, visible as a bright point to the right of the center of the image. You can see that little white circle. That's the planet, which is blocked out by the coronagraph mask used to block the blinding light of the center star. The black dot in the center, that's the star itself. Basically, humans categorize clumps of matter based on attributes: galaxies, star clusters, planets, planetescent dwarf planets, moonlet, Plutoids, rogue planets, moons, rings, ringlets, comets, meteorites, squirrels. Yes, they're all collections of matter existing characteristics different from one another, but obeying the same natural laws. Everything. I mean, scientists begun tallying these clumps of matter, and resulting numbers are pretty hair wild. I mean, our own galaxy, the Milky Way, it contains about 100 billion stars, and the observable universe contains about 100 billion galaxies. Yes, Yvette, approximately 85% of dark matter energy, theoretically. Theoretically, I know. If all the galaxies were all the same size, that would give us 10,000 billion, or 10 sextillion, stars in the observable universe. But the universe also seems to contain a bunch of matter and energy that we can't see or directly observe. Dark matter, dark energy. Yeah, I know. All those stars, planets, comets, sea otters, black holes, unicorns, dung beetles together, everything represents about less than 5% of the stuff in the universe. Yeah, like Yvette said, approximately 85% of dark matter energy theoretically known. Theoretically. This is her field of expertise. She's a quantum physicist. This next image I wanted to show you guys, since Yvette already said what I was going to say. This is two views from the Hubble and our massive galaxy clusters. It's the C0024 plus 17 and ZCI 0024 plus something. Sorry, I can't remember all those numbers. Do not be offended, Yvette. That was a great sum up right there, what you said. When I was talking about dark matter, dark energy. That's a great sum up. Thank you anyway. I was talking about the galaxy clusters. On the left side of the picture here is viewed light through visible light, with some odd-looking blue arcs appearing among the yellowish galaxies. These are the magnified and distorted images of galaxies located from far behind the cluster itself. I mean, their light is bent and amplified by the immense gravity of the cluster in a process called gravitational lensing. To the right side of the image, I was inverted here, a blue shading area. It's been added to indicate the location of an invisible material called dark matter that is mathematically required to account for the nature and placement of the gravitational lens of galaxies that are seen here. Oh, sorry, I need another drink. I wish I could just get a long straw off my table. One of the little crazy straws. The universe is infinite and you love it. That's your hypothetical opinion and theory, then hey. Some people believe the universe is a closed loop. Some people think it's a multiverse. But I'm talking about our verse today. Of course, some people even ask, how has the view of your universe changed over time? Well, human understanding of which the universe has changed, well, many people had little or no meaning of the understanding of the universe. I mean, our distant ancestors, they relied upon myth and legends and word of mouth and fire stories to explain everything, because basically they invented them. I mean, these myths reflect human concerns, hopes, aspirations, or fears rather than the nature of a reality. I mean, A few hundred years ago, humans, we began to apply mathematics, writing, and new investigative principles to search for knowledge. I mean, these principles were refined over a period of time, as were scientific tools and methods, eventually revealing hints about the nature of the universe. Only a few hundred years ago, these principles were basically applied when people began systematically investigating the nature of things. I mean, the word scientist didn't even exist back then. Researchers were basically called natural philosophers. I said that in quotes because they were called natural philosophers. I mean, since then, our knowledge of science has only done leaps and bounds forward. It was only about 100 years ago that Hubble, he discovered that galaxies beyond our own. And only about 50, 60 years ago passed since humans first began sending spacecraft to other worlds. I mean, in the span of a human, get this, in the span of a human lifetime, space probes have voyaged through the outer solar system, sent back the first images close-up of 4 giant outermost planets, countless moons, rovers going on the surface of Mars for the first time. We constructed a permanently crewed orbiting space station, 3 of them, Skylab, Mir, Skylab, and now the ISS. We have a telescope in outer space, the Hubble, and soon the James Webb. I mean, we are exploring and expanding our scientific knowledge about everything right now. We discovered thousands, not hundreds, thousands of planets around other stars. We detected gravitational waves for the first time. And this, you can see, is the very first image of a black hole. This was taken by the EVT, the Event Horizon Telescope. This right here is the black hole at the center of the galaxy M87. And speaking of galaxy M87, I have some scientific news for everybody. Yes, there's scientific news right now. I'm so excited for this because today, March 24th, the ESO, European Southern Observatory, released a brand new image. What's this image? Astronomers' image of magnetic fields at the edge of the black hole itself. Check this out. This is awesome news. This is the brand new released picture today. The EHT is a collaboration. They produced the very first image of the black hole. Today, they revealed that this new image right here, this is how it looks in polarized light. This is the first time astronomers have been able to measure polarization, a signature of magnetic fields. This is very close to a black hole. I mean, the observations are key to explaining how the M87 galaxy, which is located about 55 million light years away, is able to launch energetic jets from its core. I mean, light becomes polarized when it goes through certain filters, like the lens of a polarized sunglasses, or when it is emitted in hot regions of space where magnetic fields are present. In the same way that polarized sunglasses help us see better by reducing reflections and glare from bright surfaces, astronomers can sharpen the view of the region around the black hole by looking at how the light originated from its polarization. Specifically, polarization. This allows astronomers to map the magnetic field lines present at the inner edge of black hole. I've got to show you this image right here. I'm sorry. This next video I'm going to show you, this video zoom starts with a view of Allah. It zooms in on the heart of M87. It's showing successfully more detailed observations as it zooms into M87. First released in 2019, the image released in 2021, how this supermassive object looks in polarized light. This is the first time astronomers have been able to measure polarization. a signature of magnetic field this close to the edge of a black hole. If you want some more information, I just updated the page. All the information from ESO and the information of the black hole news is right now. You just got to refresh it. It's all in the description below. You have the link. You have a way to download the video. There's more scientific news and information for you. I love this news. I mean, with ever advancing technology and knowledge, with no short of imagination, we can continue to lay bare the science and the secrets of the cosmos. I mean, new insights and inspirations notion aided basically in this pursuit and also springs from it. We have yet to send a space probe to even the nearest of the billions upon stars through our own galaxy. I mean, we haven't explored our own world, our own solar system. In short, most of us in the universe, most of the universe that can be known remains unknown. I mean, the universe is about nearly 14 billion years old. Our solar system is about 4.6 billion years old. Life on Earth existed for maybe about 3.8 billion years old. And humans have only been around for a few 100,000 years. The universe has existed roughly about 56,000 times longer than our own species has. I mean, by that measure alone, almost everything that's ever happened did so before humans existed. So, of course, we have a lot of questions in common sense. We just got here. I mean, our first decade alone of exploring our own solar system are merely a beginning. I mean, from here, just one human lifetime from now, our understanding of the universe and our place in it will have undoubtedly grown and evolved in ways we can only today imagine. One of our fundamental questions today is, are we even alone? I mean, the search for life beyond Earth is just getting started. Of course, science has encountered very early answers. There are plenty of planets in the galaxy, with many similar to our own, but we don't know what fits these questions in these volumes. I mean, observations from ground and from space have confirmed 1,000 planets have existed. We have discovered over 4,000 exoplanets. Our own galaxy holds possibly trillions, but so far we have no evidence of life beyond Earth. Is life in the cosmos easily begun, or commonplace, or is it rare? I mean, we have the James Webb Telescope coming up. So far, the only thing we know about life right now is what we have on Earth. The James Webb Telescope, scheduled to launch this year in 2021. Hopefully, it does not get pushed back again. It could get the first glimpses, basically the mix of gas in the atmosphere of Earth-sized exoplanets. James Webb, or maybe a similar spacecraft in the future, could pick up some signs of an atmosphere like our own. I mean, you need oxygen, carbon dioxide, methane. A strong indication of possible life, water. I mean, future telescopes may pick up significant phosphonus, basically phosphates like we found on Venus, but further away. The transformation of light into chemical energy by plants, osmosis, or even gases and molecules suggesting the presence of animal life. Intelligent, maybe. Technological life might create atmospheric pollution, as it does our own planets, also detected by from afar, which we are still looking for. And of course, one of the best may be able to manage is an estimated probability. Still, an exoplanet would say maybe 95% probability of life would be a great game changer for humanity in itself. I mean, how would we actually find life? It may turn up our own neighborhood beneath the Martian surface. Hey, that's what curiosity is there for, right? Or in maybe a dark subsurface ocean of Europa. We don't know yet. I mean, we lived through with spectroscopy. Yeah, I know. Even C.S. Lewis didn't think we were alone in the universe. We're not going to believe it until we see cities on distant planets. Well, Bert, if we see cities on a distant planet, that happened a long time ago. We're not sure if that civilization is still there or not. That's why we use spectroscopy. This is an example, okay? It's basically the simple science of measuring the intensity of light at different wavelengths. This graph right here I put on the screen, right here. It's a representation of these measurements. These are called spectra, and they are the key ingredient to lock in the composition of exoplanet atmospheres. See, when a planet passes in front of a star, the starlight passes through the planet's atmosphere. If, for example, the planet has sodium in its atmosphere, the spectrum of the star adds to that of the planet will have what we call an absorption line. In the place of the spectrum, you can see the sodium. I mean, this is because different elements and molecules absorb light at characteristic energies. And this is how we know where in a spectrum we might expect to see the signature of sodium or methane or water if it is present. I mean, getting a stroke of odd luck here. We actually happen to find life. The job's going to be really, really hard. Light will be the key. Light from atmospheres of exoplanets, split up into a rainbow spectrum that we can read like a barcode. Yeah, I said barcode because everybody knows what a barcode is. Basically, this is what is called transit spectroscopy. This will provide a menu of gases and chemicals in the sky of this world, including those that may be linked to life. I mean, life as we know it. They actually dwell in the cosmic pools of Yosemite Park, in the dry valleys of Antarctica, superheated vents of the ocean floor. They belong to branches of life that split from our own billions of years ago. These little creatures are called extremophiles, or life forms that love extreme environments. They love thriving conditions that would kill almost anything else. But, these also might be analogs of strange life on distant worlds. So, where should scientists look? Like I said, there's over 4,000 exoplanets we found around other stars that have been confirmed to exist in our very own galaxy. One of the best tools scientists have began narrowing the search for habitable worlds is a concept known as the habitable zone. It's the orbital distance from where a star and temperature would be potentially allow liquid water to form on a planet's surface. Mainly other conditions also will be required. And a stable star not prone to erupting and sterilizing flames. I know there's some criteria for the habitable zone. These are our own observations of what habitable zone is to life as we know it. It's really just a way to make the final first cut and zero on the planet with the best chance of possibility of having life. So what exactly is the habitable zone? When searching for possible habitable exoplanets, it helps us start with worlds similar to our own, as life as we know it. But what exactly does similar mean? I mean, many rocky planets have been detecting Earth-sized ranges, like a point in favor of possible life. Besides what we've observed in our own solar system, large gaseous worlds like Jupiter seem far less likely to hold habitable conditions for any type of life. But most of these Earth-sized worlds have been detected orbiting red dwarf stars. Earth-sized planets in which white orbits around the sun's stars are much harder to exist. As you can see right here, this infograph, it compares the characteristics of these three types of classes of stars in our galaxies. Some stars like our own are classified as G stars. Stars less massive and cooler than our own stars are called K dwarfs. And even fainter and cooler stars are the reddish M dwarfs. And of course, when talking about habitable exoplanets, but we're actually really talking about those stars themselves. It's the dominant force of any planetary system. Habitable zones, not habitable zones. I mean, if the planet is in a habitable zone and potentially capable of hosting life, bearing planets, these are wider for hotter stars. I mean, smaller, dimmer red dwarfs, which is the most common type in our Milky Way galaxy, have much tighter habitable zone, as in the TRAPPIST-1 system. They are closer to the planet. Where are we looking for life? And why? What's the future of the mushroom economy, and what would it be like in Bitcoin? I don't have the Bitcoin calculator, so I cannot let you know that right now. Yes, Mr. Miles, it's called the Goldilocks zone. And I am getting a spam phone call right now, so I have to mute that. It said unknown, so that's got to be a spam. Where was I? Oh, yeah, 42. So, where are we looking for life? And basically ask, why? I mean, life on other planets might be nothing like on Earth. It could be life as we don't know it. Yeah, life as we don't know it. Oh, there it is. But it makes sense, at least at first, to search for something more tangible and familiar to what we understand life as we know it should be easy to find. I mean, the light's better in the habitable zone of the area around the star where planetary surface temperatures could allow the cooling of liquid water. Other similarities to Earth come into sharper focus in the search for life. Many rocky planets, they have been found detecting Earth-sized range. It's a point in favor of possible life. Based on what we have observed in our own solar system, Jupiter, Saturn, they're unlikely to have life on the planets itself. Because our star has nurtured life on Earth for nearly 4 billion years, conventional wisdom would suggest that stars like it would be prime candidates in the search for other potential habitable worlds, G-type stars like our own sun. Of course, they are shorter lived and less common in our own galaxy. Stars slightly cooler and less luminous than our own sun, called orange dwarfs, are considered by some of the scientists as potentially better for advanced life. Our summer life limited to 1, so it's really hard to search for what we don't know exactly. Where do you fall in love with the idea of panspermia? I love the idea of panspermia. Oh, in case anybody doesn't know what panspermia is, it's a theory that microbial life or the ingredients for schnapps, sodium, carbon, hydrogen, oxygen, nitrogen, sulfur, they were on meteorites and asteroids and comets when they hit the Earth. Sorry. Oh yeah, I was talking about the orange dwarfs. The orange dwarfs, they are considered by some of the scientists to be potentially better for advanced life. I mean, they can burn steadily for 10 billion years. This opens up to a vast timescape for biological evolution to pursue on an infinity of experiments for a chance for life forms. For every star, there is at least 3 times as many orange dwarfs in the Milky Way galaxy alone. K dwarfs are the true Goldilocks stars, said Edward Guinan at Billigan University in Villanova, Pennsylvania. He said this, quote, sorry, I want to read this quote, Mr. Miles, I got my notes here. K dwarf stars are in the sweet spot, with properties intermediate between the rare, more luminous, but shorter-lived type stars, G stars, and the more numerous red dwarf stars, M stars. The K stars, especially the warmer ones, have the best of all the worlds. If you're looking for planets with habitability, the abundance of K stars pop up chances of finding life. Actually, I do believe life did have a chance to form some kind of form, because about 3.5 billion years ago, Mars and Earth had the same amount of atmosphere, according to studies that Curiosity has done and Sojourner has done. There was liquid water, evidence of liquid water on Mars, because you can't get the round pebbles without turning of a liquid. And the only thing that's able to flow on the surface of Mars liquid would be water. And there is water on Mars, by the way. This is basically a simple little map of the habitable zone. Excuse me. Exoplanet temperatures, size, star type. I mean, the galaxy offers up a huge wide variety that echoes the aspect of our own. Of course, some are vastly different, some are vastly the same. TRAPPIST 1. If an alien civilization was to look upon our solar system, it would detect 3 planets in the habitable zone: Venus, Earth, and Mars. Just because a planet's in the habitable zone does not mean it's suitable for life as we know it. It all depends on the location of the star, the type of star, the type of planet it's going through. Like Venus, it went through a greenhouse effect. We still don't understand why. We still don't understand what happened to Mars' atmosphere and water. We still don't even know this yet. It could have been. That's a possibility. There was a period in the universe when its temperature was just right for liquid water in the void. Life may have begun in the molecular cloud containing a lot of water. Possibly. Possibly. Listen, I want to thank everyone for joining me. And before I end the show, I want to ask the community something. I have been thinking about expanding my show and by getting a USB eyepiece camera. I can get a very, very, very cheap one, which is only about 70 times magnification. But a very good one costs about $130 to $250. I was thinking about doing a little online fundraising to raise for this. If you look back at my show, my videos, you will see I did the one-chip challenge. I succeeded. I won. What I'm thinking about doing is another spicy hot challenge and do my show at the exact same time while I'm doing the challenge. No video, just do a show on science and astronomy and astrophysics while I'm doing a hot food challenge. If anybody is interested in any ideas I can do this with, please leave a comment in below. You want to see me suffer and burn my mouth and my esophagus while I do a show talk about science and astrophysics? Leave a comment below. And I want to thank everybody else for joining me here. So I want to thank everybody, and you guys all have a good day.